Alright, in this video we're going to talk about tangent lines and tangents to a circle. Okay, and what that's all about, what it looks like, and how you can solve some problems with it. First thing, what is the definition of a tangent line? Definition of a tangent line is a line that lies in the plane of a circle, which means it's flat like the circle is, that intersects the circle at exactly one point. Intersects the circle in exactly one point. We call that one point the point of tangency. Okay, so this example right here, this red line is a tangent line. Line CB is a tangent line to this circle, circle A, and it intersects the circle exactly once at point C. We call that the point of tangency. Okay, so if we have a tangent line, there's all sorts of things that could be true about this. First thing is this. It says if a line is tangent to the circle, then it's perpendicular to the radius at the point of tangency. So here we have this line that's tangent to this circle, meaning it intersects the circle exactly one time. If you were to draw a radius to that tangent line, it would always be a right angle. It's always going to be perpendicular. Okay, so how can we use this? We can see an example right here where it says AB is tangent to the circle C at the point B. So the line AB is tangent to circle C. Again, we just said that if it was tangent, this is going to be a right angle. These are perpendicular to each other. And why do we care if it's a right angle or not? Well, if it's a right angle, it says if AC is 25, we already know right here AB is 15. We want to find the radius. Well, the radius of this circle is from the center to the outside of the circle, so from C to B, and we want to find the radius. Actually, I'm going to call it R. Okay, so how do we find the radius? Well, what do we see now? What shape do we have? We have a triangle, more specifically a right triangle. If I know two of the sides of a right triangle, I can find the third by Pythagorean theorem. So R squared plus 15 squared is equal to 25 squared. I'm going to leave R squared by itself. 15 squared is 225, and 25 squared is 625. We can subtract out 225 on both sides. We're left with R squared is equal to, well, 625 minus 225 is 400. How do you get rid of the R squared? How do you get rid of squared? You take the square root, so we end up with R is 20, because the square root of 400 is 20. So the radius is 20. The next thing we could do with this, well, if ML, line ML, and line MN are both tangent to circle O, ML and MN, these two lines, if these are both tangent to this circle O, that means that angle N right here is a right angle, and angle L right here is a right angle. Why do we care if those are right angles? Well, now, if we look at the bigger picture, we see a quadrilateral four-sided figure, LONM, this quadrilateral. And we already know three of these angles on the inside. We know this is 90 degrees, we know this is 117, we know this bottom one is 90. I want to find x. If you remember from previous units that the inside angles of a quadrilateral add up to 360, we can just say 117 plus 90 plus 90, and we end up with 297 for all three of these angles. If again all of them have to add up to 360, we say 360 minus that 297, and we're going to be left with the angle that we don't know, our x. So 360 minus 297, and we get 63. So the angle x is equal to 63 degrees. Next question. This is one of the examples on our worksheet. Example number 1. So we want to find this inside angle, this interior angle. Okay, on the instructions that I didn't copy over, it did say that this line we're going to assume to be a tangent line, and this line we're going to assume to be a tangent line. So if they're both tangent, that means that this is a right angle and this is a right angle. So how do I find the angle x? We find it by adding up the three angles we already know and subtracting it from 360. So we say 60 plus 90 plus 90 9 plus 9 is 18. 18 plus 6 is 24, so we get 240. Then we take 360 for the entire four-sided figure. Subtract out 240. We're left with 120 degrees. So x is equal to 120 degrees. The next example, this is number 3 on our piece of paper. Okay, this one's a little bit different. On here, there's an extra line drawn right here. I'm actually going to try to pull this picture out even bigger. Okay, we want as much space as we can get. So this 60 degrees means that this inside angle right here is 60 degrees. And if you remember, if we're going to assume that this is a right angle or a tangent line, we need to remember that it makes a right angle right here with the radius. Okay? So how do I find this? Well, I can use that right angle and the 60 degrees given to me to find this portion of it. I'm going to try to highlight it in a different color. I want to find this angle right here. I'm going to explain why in just a second. So again, the whole thing is 90 degrees. This part of it is 60. So the other part is going to be 90 minus 60, which is 30 degrees. So this is 30 degrees. So why do we care about that? Okay, we care because we know that a tangent line and a chord, intersect at an angle, and that angle is going to be half the arc, the intercepted arc. So I'm actually going to use that to find this arc. Okay, this arc, again, the angle is half, so we say 30 times 2 to get 60 degrees. So the arc is 60. Okay? Then what we can do is say that this is a central angle right here, central angle, and it's equal to the exact same measure as our arc. So if the arc is 60 degrees, the central angle is 60 degrees. Okay. So then we have a 90-degree angle for this triangle now, 90-degree angle, a 60-degree angle, and then we have x. So we say 90 plus 60, you get 150. All three angles on the inside of a triangle have to add up to 180, so we say 180 minus 150, and we get 30 degrees. So that's what x is. X is 30 degrees. Okay? The next example, again, we're going to assume that this is a tangent line. And if it's a tangent line, it makes a right angle with the radius. The question on this one is actually asking, I didn't copy it over, but it's actually asking, does this make a tangent line? So the question is it a tangent line? Okay, to find out if it's a tangent line, we're going to go ahead and assume that it is. And if it's a tangent line, again, it would make this right angle with the radius. So then this should follow Pythagorean theorem because now it's a right triangle. So my question is, if Pythagorean theorem works, if Pythagorean theorem actually does work, then yes, it is a tangent line. If Pythagorean theorem does not work here, then this can't be a right angle, and so this is not a tangent line. Okay, so we're going to pretend like it does. So we're going to say 5 squared plus 15 squared is equal to 16 squared. I know this kind of looks weird because it's already filled out for us. We're going to see if these are actually equal to each other. So 5 squared is 25. 15 squared is 225. And 16 squared is 256. If we add 225 and 25, we end up getting 250 is equal to 256. Is this true? No, it's not. 250 is not the same as 256. So this Pythagorean theorem does not work. So is this a tangent line? No, this is not a tangent line. Okay, the next question is asking the exact same thing. So is this, oh no it's not, never mind. This is actually asking, so yes, this is a tangent line. We want to find the radius, okay, this x. The interesting part is this 7 only goes with this section, because this part right here is also the radius, which is x. So this is going to be an interesting one to try and solve. Again, since it is a tangent line, it's going to make a right angle with the radius. So then how do we solve this? Well, we want to set up Pythagorean theorem normally. So we say one leg, 10 squared, plus the other leg, x squared, is equal to the hypotenuse squared. Well, what's the entire side? This section is 7, this section is x. We're going to add it together so we get 7 plus x, and that's the whole side. But again, we're going to square this whole side. So we have 7 plus x squared. Put that in parentheses because it's not just 7 squared, it's not just x squared, it's the entire thing squared. Okay, so 10 squared is 100, x squared is still x squared, and this is interesting right here. We need to remember how to multiply together, multiply this, because it's not 7 squared and x squared. This is actually saying 7 plus x times 7 plus x, and I'm actually going to write that up here. Okay, 7 plus x times 7 plus x. There were a couple different ways that we solved this. We had FOIL method. We also had the box method. Any way you want to do it, that's fine. I'm actually going to do it by FOIL, which means first. So 7 times 7 is 49. Plus first outside, 7 times x is 7x. Inside, 7 times x is again 7x. And last, x times x is x squared. I can go ahead and combine these. 7x plus 7x is 14x. We get 49 plus 14x plus x squared. And this whole thing is being plugged in right here. Okay, so 49 plus 14x plus x squared. Okay, to solve this, I'm going to go ahead and subtract x squared from both sides. So minus x squared. These cancel out. Interestingly enough, those cancel out, so we're left with 100 on the left side and 49 plus 14x on the right side. Now I'm going to get rid of 49, so subtract 49 from both sides. 100 minus 49, we end up with 51 is equal to 14x. Let me extend the page. Okay, how do I get rid of the 14? I divide by 14. So we end up with x is equal to 51 divided by 14 is, interesting number, I'm going to go ahead and round it to the nearest tenths place, so we get 3.6. And that is our x. Okay, I understand this was pretty involved. There was all sorts of stuff going on here. Okay, we could check our work. We could say if this is 3.6 and this is 3.6, well 7 plus 3.6 is 10.6, and this would be 3.6. We need to say 10 squared plus 3.6 squared. And does that equal 10.6 squared? Okay. It's pretty close, actually. That's because we rounded. So it is slightly off, but yes, we did get the correct answer, 3.6. Okay. Something else that you can do with tangent lines is if you have two segments that are both tangent lines, so for example, AB, or part of a tangent line, so AB is part of this tangent line, so it's going to be tangent to that circle, and CB, which is part of this tangent line, those are actually going to be congruent to each other. One hash mark's already drawn, here would be the other one, so these are going to be congruent to each other, so BA, segment BA, would be congruent to the segment BC, and this is going to be always true for a circle. So this is an example of it. So again, these lines intersect the circle just once in those 3 points. So BC intersects the circle one time right here, so BC would be a tangent line. BA would be a tangent line, intersects one time, and AC would be a tangent line, intersecting one time. The whole question is asking for the perimeter. Okay, perimeter. So to find perimeter, we need to find all the sides. but we don't know all the sides yet. So how do we do that? Again, from the last slide, we said that if two tangent lines intersect somewhere outside the circle, that means that those segments are going to be congruent to each other. So if this one's 5, this one has to be also 5. If this one's 10, this one's 10. This one's 3, this one's 3. Now we can add these up. 10 plus 10 plus 5 plus 5 plus 3 plus 3. 10, 20, 25, 30, 33, 36. So my perimeter is 36. Again, just add up all the sides. It does say that all numbers indicate inches, so this would be in inches. Another question for this. It says RA is 12 meters. RA is 12. If TC is 5, and the measure of angle CTR, this whole thing, is 150 degrees, we want to find a couple other pieces. So I'm going to do one piece at a time. First of all, I know that RA is a tangent line, meaning this intersects at a right angle. I also know that CA is a tangent line, so this is a right angle. Again, if we have two tangent lines that intersect at some point outside the circle, it means that both of those segments are congruent to each other. So if RA is 12, CA is 12. Similarly, TC is a radius, which is 5. TR is a radius, so it also has to be 5. So we've already answered a couple things. So TR is 5, CA is 12. We want to find TA now. TA is this slightly longer segment, or looks longer at least. So how do we do that? Well, since this is a right angle, I make a right triangle. TRA. TR and A connect together to make a right triangle. This is a right triangle. We can, if I know two sides of them, we can find the third by Pythagorean theorem. So we can say 5 squared plus 12 squared is equal to, I'm going to call it x squared, or that's our segment TA. 5 squared is 25. 12 squared is 144. It's equal to x squared. 25 plus 144 is 169. It's equal to x squared. To get rid of the squared, we take the square root. So x is equal to square root of 169, which gives us 13. So TA is 13. This next part, angle, measure of angle, RAT. RAT. This is what we're trying to find right here. This is actually a pretty interesting one. If we notice, this segment, the radius, and this segment of the radius are both congruent to each other. CA and RA are both congruent to each other. So we have a four-sided figure where the two sides next to each other are congruent to each other. This is actually a kite. If we remember on a kite, the diagonal, or TA, actually bisects opposite angles, meaning this 150 degrees is cut in half. So if we divide 150 divided by 2, we end up with 75 degrees. So this part up here is 75 degrees, and this part down here is 75 degrees. To define the measure of RAT, angle RAT, we already know two angles on the inside of the triangle, and all three have to add up to 180, so we say 90 plus 75, and we get 165. Then we subtract that from 180. We're left with 15 degrees. Okay, so angle RAT is 15 degrees. There were actually quite a few different questions in that one. There are 4 total. We found TR, we found CA, we found TA, and we found the measure of angle RAT. All because these two segments are both tangents. Okay, we got one more on here. This is on our worksheet again, number 12. The question's asking for the perimeter, so we need this distance in order to find it. So how do we do that? First, what we're going to do is say, well, if I know this line intersects the circle at this one point, meaning it's a tangent line. This line intersects the circle at this one point, meaning it's a tangent line. This line intersects the circle one point, meaning it's a tangent line. And the last one also, meaning it's a tangent line. Okay, if I know this portion of it is 1.9, and again, if a tangent line intersects another tangent line, somewhere outside the circle, then these pieces have to be congruent to each other. So what we're going to do is basically go around the circle. So if this one's 1.9, this one's 1.9, meaning this part has to be, well, whatever 3.4 minus 1.9 is, and 3.4 minus 1.9 gives us 1.5. And again, if this is 1.5, this is 1.5. So how do we find this one? Well, it's 3.6, this side, minus 1.5. And we end up getting 2.1. If this is 2.1, this one's 2.1. If this is 2.1, what is this section? Well, if this is 3.7, we say 3.7 minus 2.1, and we're left with 1.6. So if this is 1.6, what is x? 1.6. So then how would we find the perimeter? We need to add up all these pieces together. So we're going to say 1.6 plus 1.6 plus 2.1 plus 2.1 plus 1.5 plus 1.5 plus 1.9 plus 1.9. And what do we get? Let's see here. Okay. We end up adding all of them together. We end up getting a perimeter of 14.2. Okay. This would be in inches also. Okay, inches. That's it for today. This is over tangent lines. Good luck.